Hello, everyone. Thank you for standing by. As a reminder, this event is being recorded and will be archived on pumpsandsystems.com. I'm Amy Hyde, editor of Pumps and Systems Media. Welcome to How to Use AODD Pump Technology to Improve Processing, sponsored by Uniblock Hygienic Technologies. Our presenter today is James Murphy. James is the Director of Sales for Uniblock Hygienic Technologies and former president of Standard Pump, Inc. James has 23 years of pump manufacturing experience with an extensive background in both industrial and hygienic applications. At this time, it is our pleasure to begin the webinar. Stay tuned after the presentation for the Q&A session. Please send your thoughts through the Ask Question box throughout the presentation. It should be located in the top right box on your screen, and we'll get to as many of them as possible. Now I'll turn it over to James to begin the presentation. James?
Hey, thanks, Amy. And yeah, thanks everyone for being on today. So yeah, looking forward to talking to everyone about some diaphragm pumps. So just to kind of set the framework here for our conversation, a couple things we're going to learn. The definition of an AODD pump, construction, key features. We're going to talk applications. You know, where do you use them and why would you use them at one particular point in time versus another? We're going to look at some case studies. We're going to look at where in particular markets that we're using them. And we're going to look at some maintenance, some features and designs that can enhance maintenance. And then we're going to take some questions and answers as well. And yeah, feel free to sprinkle in your questions as we go so that we can have a collaborative exchange of ideas here. All right, so we're going to start here with the universe of pumps, and where does an AODD pump kind of line up in the scheme of all the different pump technologies that are out there? So AODD pumps is what we're going to focus on today, but there's some other technologies out there that most of you are probably familiar with. So rotary low pumps are one. That's a positive displacement pump that utilizes two rotors. Next is a gear pump. So as the name would imply, it's got two gears, almost kind of looks like the internal workings of a watch. Again, another positive displacement style pump. Then we're moving on to centrifugal pumps. So a centrifugal pump is uses centrifugal force created by an impeller to transfer very low viscosity type products. And then a newer technology to the hygienic space would be our twin screw pumps. And again, that is a positive displacement pump that is, you know, a little bit newer to the scene. And then finally, it's our progressive cavity or progressive style pumps. And this is what uses a rotor and stator type pump principle. So today, like I said, we're going to focus in on air operated double diaphragm pumps and where they play a role in our process. So some key features of a double diaphragm pump. You know, some of the things that you've got to consider when you are utilizing one of these are, you know, what is the product treatment attributes look like? In other words, can the product be damaged when we're pumping it? Or is it something that product degradation is a major challenge? So with many types of pumps, like a centrifugal pump, product degradation is very much a part of the process. But with a diaphragm pump, depending on the nature of the product you're pumping and the speed, we can slow those pumps down so much so that you can really protect the nature of the product that you're pumping. Maintenance, you know, where does maintenance play a role? Is this something that we need to take the pump apart every day for cleaning, every week, every month? So just, you know, what does that kind of look like for your facility? And then what are the facility requirements? You know, are you in a dairy where you've got to take a pump apart all the time for cleaning, make sure that there's no bacteria that's growing in the pump? Or is it more of an industrial type application where it's really not necessary? And then we're going to talk a little bit about CIP versus COP. CIP representing clean in place. And that is essentially where we would take a cleaning agent, maybe like acetic acid. We would pressurize it, heat it up to 185 degrees approximately, and we're going to use that to run through the system to clean the actual pipework, the pump, valves, and everything involved. Whereas COP means clean out of place, and that's essentially where you just take the pump apart and then you put all the individual components into some type of parts washer or cleaner. And then performance. Do we need something that produces a continuous flow of product, or is pulsation okay? Or do we have some solids involved, or high viscosity or low viscosity? So all these different things we take into consideration when we're looking at different types of diaphragm pumps. And I see there's a couple questions rolling in. Let me cover a little bit of this content here, and then we will address some of those as well. So air-operated double diaphragm pump, what is it? So as you can see pictured here, there's a couple different configurations. You've got a traditional, more figure-8 design on the left and right here. And this is a design whereas you have your air motor, which is the driving force that drives the diaphragms, or shifts the diaphragms left to right. And then you've also got the configuration that you see here in the center, and that is essentially where your liquid end is in the center and your air and your diaphragms are on the exterior. So two very different types of designs. In terms of performance, they act very much the same though. In terms of your applications in the materials of construction, that very much is dependent on the product media or the type of application in which you've got the pump involved. So as an example, there's a couple different materials out there for more industrial base applications. And those common materials would include PTFE, Buna, polypropylene, PVDF, and some others along those lines. And then the diaphragms, of course, play a role. And in that case, we have PTFE, or we've got some elastomers such as Buna, there's some nitrile and EPDM. So again, things to consider when you're picking out your materials are the nature of the application, and then the media in which you're pumping, and then also the temperature. And temperature range of diaphragm pumps can extend anywhere from -40 degrees all the way up to 135 degrees, and that's Celsius. So when you think of like the very cold temperatures, the extraction process of CBD oils comes to mind. Or oftentimes when you're in an industrial application and you're pumping some aggressive chemicals, oftentimes they'll be in the 160 to 170 degree Fahrenheit range. So one of the nice things about diaphragm pumps, as I mentioned earlier, they're available in a lot of different materials construction, stainless steel for your food grade applications or pharmaceutical applications. But then we've got the chemically resistant materials construction, like I mentioned, the polypropylene PVDF. So a very diverse range of materials creates the opportunity to use these pumps in several different applications and markets, and oftentimes inside the same facility. So let's go ahead and answer a couple of those questions if we could.
Sounds good. Okay, so one of the questions has come in. What are situations where you would definitely not use an AODD and should use a lobe or gear pump instead?
Yeah, that's a great question. So oftentimes air-operated diaphragm pumps, as the name would imply, they're air-operated. So if it's a situation where they don't have access to air and they only have an electric option, for most manufacturers, then that would be the case that they'd have to go to a different type of technology. But I would also say probably the biggest opportunity to only use electric would be, or not use a diaphragm pump rather, is when they don't need or they can't have any type of pulsation on the discharge side of the pump. And that's when they have to look at some other technologies. And I would say something like a progressive cavity style pump would probably be a better option for that.
Okay. Another question that we've got here, can an AODD pump be completely submerged?
So the short answer to that is yes, it can. Now that is dependent upon the application itself. So we don't see that in the hygienic space, but there are some industrial applications or dewatering type applications where they do. One thing to keep in mind is that we've almost got to create a snorkel for the muffler or the discharge so that air can actually be discharged out. But yeah, technically, industrial diaphragm pumps could be submerged.
Okay. One more, and then I'll let you get back to the presentation. Are there any inlet pressure limitations?
Yeah, so that's a great question. And I'm assuming that refers to the air pressure, or is that going to be more about the product inlet pressure?
Joe, if you can send any clarification for that, I'll throw that back over to James.
So I'll go ahead and address the inlet pressure, not on the air to the motor, but actually the inlet pressure of product coming in. Because sometimes we see applications and where it's a gravity feed type situation, but the product or the media coming into the pump is under pressure. So let's think in terms of like a brewery. If you're using a diaphragm pump in a scenario where it's strategically placed between the bright tank of the beer, and then it's placed between the bright tank and the filling line, there are applications where you could get some inlet pressure that could exceed like 25 to 30 psi. And in that case, there's only a few types of diaphragm pumps out there that can handle that. So I would say broad scale, traditional diaphragm pumps can only handle an inlet pressure of 12 psi. Anything above that could create damage to the diaphragms and will eventually cause those to rupture. But there are a few designs out there that will enable you to use a diaphragm pump for that. In terms of air inlet pressure to the air motor, the way the pumps work essentially is for every psi in, you get 1 psi out of discharge pressure. Traditionally, most manufacturers would tell you that they don't recommend you exceed 110 psi inlet pressure to the air motor.
Okay,
So,
great.
hopefully that addressed those two questions. If you need me to be more specific, please just let me know.
Sounds good. And then just a reminder to everybody to keep sending those questions in, and we'll get to all of them. And if for any reason we run out of time, we'll make sure to get those to James so that he can answer those offline.
All right. So thank you for your questions. Keep them coming. So let's talk about a word that comes up that oftentimes describes diaphragm pumps, and that's versatility. You know, one of the reasons that these pumps are so widely spread and used in so many different industries is the fact that they can be used for multiple applications within the same facility. So if you look here, we've listed some very common applications or products rather, and the viscosity associated with them. And so you can see starting with water at 1 centipoise all the way up to like a PFA resin that honestly, depending on temperature, could surpass even 65,000 centipoise. So diaphragm pumps can be moved around the plant. Oftentimes they're put, they install wheels on them, and so they can be moved around. And we even see this in breweries where, maybe they're transferring some water, or maybe they're transferring some spent filtration agents, or in the case I used earlier, they could be transferring some beer. So oftentimes they're used for so many different applications, and that's one of the nice features is the versatility that's offered here. And you can see here the stats that 90% of industrial plants have at least one diaphragm pump. Even on the food side, we've even seen it where they're using diaphragm pumps for their process for packaging or bottling. But then they may have a pump that's used for dewatering or used on the water treatment side of the business as well. So just really nice in terms of the versatility there. All right. We're going to move on to the next slide. So the construction of a AODD pump. Now, the one that you see here is a little bit different than a more traditional design. But at the end of the day, they both have a liquid end, and then they have the air side of things. And there's a drive shaft between them, oftentimes are described as a spindle. And that connects two diaphragms that shift back and forth. And then essentially that shifting process is what creates our pumping action. So you can see that in this case, you've got two diaphragms and 4 check balls. And the ball seats and the flow chambers are all designed proportionally so that as the product shift, or as the diaphragm shift one way, the check balls release on the opposite side. And that's what creates our pumping action. As I mentioned earlier in the presentation, there's a lot of different materials construction, really just depending on the nature of your application here. Just a couple you see here: the aluminum, polypropylene, PVDF, stainless. Then we even get into some of the exotics. So Hastoy C, that is one that's used for some pharmaceutical or some really chemically aggressive environments as well. And then PTFE, oftentimes those are used in your more high purity type applications. So getting back to the construction here, you've got the foot of the pump, which sits at the bottom, and then you've got an inlet and a discharge as well. And those can be configured in a number of different ways. So in the case of this drawing here, the inlet's on the bottom, the discharge is on the top. But we also see configurations with a more traditional design where they will have side porting. So on the left or the right side, you'll have both your inlet and your discharge. What remains the same, though, is regardless of the port configuration, the inlet is traditionally always on the bottom and the discharge is on the top. And then we also have even seen some configurations where you see here it's vertical, but there are configurations where they will actually horizontally mount a diaphragm pump. And where we see that mostly is when they're moving some very large solids and they're using a flapper check design. And what that does is by putting in that horizontal orientation, it actually reduces the friction and makes it easier for that pump to move some of those larger solids through. All right, we will keep moving here. So this gives you a little bit more of an up close look of the actual pumping mechanism here. So you can see in this configuration, you've got the check balls, which are obviously those 4 black balls. And then you've got the 2 diaphragms, one on the left and one on the right. And so as you can see, the media is represented by the purple color. So as the left diaphragm shifts to the left, you can see the product is actually going in, it's vacuuming in or pulling in on the right. And then as it shifts right, it's positively displacing that product up. And then now it's pumping or it's vacuuming in the product on the left side. And this process just continues over and over. So let's talk about some key features of a double diaphragm pump. So when you think of a traditional pump, a mechanically sealed pump, 2 things come to mind that you can't do. One is you can't run the pump dry, typically, and number 2, you can't deadhead. For those of you who aren't familiar with that terminology, we're not talking about the Grateful Dead, but we're actually talking about pumping against a closed valve, to where the pump would be pumping against a closed valve, which would ultimately damage a mechanical sealed pump. In the case of a diaphragm pump, though, we can do both of those things. We can run it dry, we can deadhead the pump. The pumps are considered self-priming, usually up to 14 to 15 feet. The simple design, as you see pictured here with this particular pump, this pump is held together by a very large hex nut. There's no tri-clamps, there's no bolts. Literally the entire pump is held together, and which makes it very easy for assembly and disassembly, but just by that one nut there. And something else that's nice about it is since it's not electric, we don't have to use a VFD, and that's a variable frequency drive. We just adjust the flow rate and the pressure by the air. So depending on the air inlet and the size and the amount of pressure we have, we can just use a ball valve to adjust that as well. And then as we pointed out earlier, the fact that they're low shear and they don't damage product also makes them a real nice advantage. Let's talk about cost of ownership and mobility. As I mentioned earlier, it's nice that you can move the pumps around a plant. And then, oftentimes we'll see them put on carts, on trolleys, or just put on some casters, and they can move them around. In terms of the cost of ownership, the wear items on these pumps are going to be 2 things. It's going to be your diaphragms and your check balls. Diaphragms being more so than the check balls, but that's really going to be determined based on the product that you're pumping and how aggressive the environment it is. So if you're pumping something that's very abrasive in nature, so let's think about something like a food product with a high sugar content like chocolate, that's going to wear on the diaphragms and the check balls, obviously a lot quicker than maybe like some type of lubricant or oil. So the lifespan of the pump is directly it's directly impacted by the media in which you're pumping. Let's talk about some other features here. So the pumps can handle some semi-solids. As I mentioned earlier, there's two major designs in terms of the valves. You've got ball checks or you've got flapper checks. Ball checks can generally handle 1/4 inch, maybe 3/4 inch solids, depending on the size of the pump. Whereas a flapper check, the largest I've seen is about a 3.8 inch solid. Viscosity. So traditional style pumps can handle somewhere in the range of about 30,000 centipoise. So when you think about that, think about a milkshake and a straw type scenario. The more viscous and the thicker and colder that milkshake is, the more difficult it is to draw the product up the straw. Same applies for a diaphragm pump. So the closer you can get the inlet to the diaphragms, the greater the viscosity capabilities. And the larger you can make the inlet of the pump, the greater your viscosity capabilities as well. So like I said, with a traditional design, that figure 8 design, 30,000 centipoise seems to be about the max viscosity. When you get into one of these center ported type diaphragm pumps that you see pictured here, I've seen it where they can handle applications up to about 150 to 200,000 centipoise. It just depends on a couple of variables such as temperature and the product you're pumping.
James, before you keep going, I was going to jump in. There are a couple of questions that have come in that are about the features. So can an AODD pump be used to pump fluidized powders, food processing?
Can a AODD pump be used to pump, what was that again?
Fluidized powders in food processing.
So fluidized powders. I don't know if I'm 100% familiar, but what I would say is pumping dry product is possible, but it can be very challenging. So it would really, really depend on the nature of that application. But I would tell you if there's any type of, if it flows at all, then most likely we can pump it.
Okay. And then another question, have you ever used an AODD pump to move dry powders? If so, do you have any recommendations to make that work?
Yeah, so kind of the same thing, but dry powders can be challenging for sure. I would say that it is possible, but it would have to definitely be in a gravity feed type situation. But there could be other technologies, quite honestly, that would probably be better. And so I would consider something that involved a auger.
Okay, great. One last question before we let you keep going. With AODD pumps, do they have a BEP or do they not have one since the air supply sets the pump on its curve?
So one more time on that.
Yeah, sure. With AODD pumps, do they have a BEP or do they not have one since the air supply sets the pump on its curve?
Yeah, that's right. So basically the air supply, which would be your pressure and air volume, that's gonna dictate the performance of the pump. And that brings up a good point is air supply is so crucial here. So some things that AODD pumps like to have are good, clean, particulate-free air supplies that are dry. And the reason for that is we don't obviously want to get moisture into those air motors and let it sit over time. But then number two, we obviously don't want any debris in there that could actually damage the pump itself as well. So, but we do see on occasion where people undersize airlines and things of that nature. So we just have to be very cognizant if the pump is not performing and you've changed diaphragms and check balls, to look back from the pump and take a look to see what your air supply situation looks like. Okay,
great. Again, everybody just keep sending those questions in and we'll keep sending them over to James.
All right. Well, I will keep going. All right. So we talked a little bit about the CIP versus COP. In terms of traditional design pumps, the figure eight configuration, that if you look back a couple of slides, if you remember, there was 3 pumps on there. We're going to talk about the figure eight design. So with the figure eight design, you can clean those pumps in place. And essentially, like I mentioned earlier, would be something like an acetic acid or some type of cleaning agent that is pumped with pressure at a roughly 85 to 100 psi at 185 degrees through the entire system. And the intent there is just to clean all the pipes, the valves, the pumps, etc. One of the challenges with some AODD pumps is the fact that inlet pressure, if it exceeds 12 psi, it starts to damage those diaphragms. But there are a few designs out there, similar to that one we just looked at a minute ago, where you've got the center porting and the air on the outside. Those pumps use a very special feature with a diaphragm backer that enables you to hit pressures up to about 100 to 110 psi inlet pressure. So it can be done. So keep that in mind when you're thinking about some of the applications in your process or your customers' processes. The other alternative would be clean out of place. So this would be where you would manually take the pump offline, take it apart, and then put those parts and wash those in some type of appropriate washer. So 2 very, very common types of cleaning products in the sanitary industry. All right, so it looks like we have a poll question here. How often do you strip your pump for cleaning? So we're going to take about 30 seconds, and we're going to allow everyone to submit their answers here so we can talk about that and get a good feel for what you guys are seeing out there. So take about 30 seconds. And it looks like we got a few more questions rolling in. So maybe after this, we'll address those as well. All right, Amy, shall we continue?
Let's move to the results.
All right, so that looks pretty common. So almost between every batch seems to be the front runner there, followed by monthly, weekly, and then daily. All right, so do we want to answer a few more questions?
Let's do it. All right, so one of the questions, are surge suppressors mandatory in AODD pumps?
They are not. That really just depends on if they want to have a pulsation dampener on the discharge of the pump. That helps with the process, but not mandatory at all.
Okay. Another question, is it possible to regulate the flow of an AODD pump?
Absolutely. That is done by the air on the air inlet side of the motor. Like I mentioned, you could use a brass ball valve or appropriate ball valve, and you can just throttle it up or down as needed. So that's how you control the pump speed.
Okay. Another question, is it necessary to have a flexible hose connected to the inlet and outlet of the pump due to its vibration?
That's a great question. And the short answer is yes. So my recommendation is that we never hard pipe a diaphragm pump in on the inlet and discharge side without having at least two to 3 feet of flexible tubing, which then connects to your hard piping or your rigid piping. What can happen is that it can shake the pipes, which is obviously not preferred, or it can actually damage the pump if the pump is really, running at a high speed. So flexible piping between the pump and the rigid piping is a very, very good idea.
Okay. Another question. Can you elaborate on any special considerations for dynamic or mechanical seals in AODD pumps compared to other pump types?
So, good question. Diaphragm pumps don't use mechanical seals. So, as we touched on earlier in the presentation, with a traditional mechanically sealed pump, you can't run it dry or deadhead it. You can do both of those things with a diaphragm pump because they don't actually have mechanical seals. They have the check balls, and the diaphragms are basically the only mechanical features inside the pump.
Okay. One more question and then we'll keep going. What spare parts are good to keep on hand?
Yeah, so my recommendation would be to always have some diaphragms, check balls, and then some O-rings for your air motor spindle. It's always recommended to have those on the shelf.
Sounds good.
All right.
Everybody keep sending those questions in.
So let's talk about some applications out in the market. So the chemical industry is obviously a big one. We've all been in plants where we've seen diaphragm pumps, typically that are constructed out of polypropylene, PVDF, maybe PTFE. And these are really nice utilitarian type applications where they're transferring some type of chemical through a filter or through the process within the plant. So they're just a transfer pump in this case. Food and beverage. So now think of applications like bottling of juices. So food and beverage, the industry, you're moving concentrates, juices, juice concentrates for that matter. But then we could even be moving some food products like chocolates, some liquid sugars, and some other types of industries or products within that industry rather. And then we're even seeing some applications within the pharmaceutical industry for diaphragm pumps. In that case, that's going to require a diaphragm pump that is constructed out of stainless steel and typically polished to a 16 RA. And RA stands for roughness area. And essentially what roughness area is, to get very detailed there for a second, is how many imperfections are in your stainless steel in a 1 inch by 1 inch square. So the least amount of imperfections, the lower the number. Then moving on to mining. So mining is actually where the diaphragm pump was invented for that type of dewatering application in mines. So I think it was in the late 40s, early 50s. There was a need in mines for dewatering, and they didn't want to have an electric motor or electrically driven pump. So that's when they came up with the idea of using a AODD pump for dewatering. And being that it's a air-powered pump, and in this case they were aluminum or stainless steel, they are inherently safe for an explosion type application. And then the other big one that we're seeing a lot of activity in are the paints and coatings. And although you wouldn't have to necessarily take the pumps apart daily for sanitation reasons, being that the fact that you're potentially pumping different colors or different colors within your process, oftentimes they want to take the pump apart for cleaning for that reason. So again, chemical, food and beverage, pharmaceutical, mining, and paints and coatings, that's not all of them, but those are some of the real big industries that we're seeing these pumps heavily used in. So, segue right into AOD pumps offer an alternative to pumps with electric motors. So, what are some of the advantages? Well, as we just talked about in the mining industry, but it could be used for transferring solvents in a plant. There's no electricity, so there's really no true ignition sources. So, when you think back to the days, I might be dating myself, but when you used to use a drill, they weren't cordless. We actually plugged them into the wall, and you could look inside the drill and see that little blue spark. That is not recommended to be used in a situation where there's flammable or combustible fumes present. So the same holds true when you're thinking of a diaphragm pump. There's nothing electric. There is no blue spark inside the diaphragm pump, so they're inherently safe for that. Something else we've got here is that we can handle viscous fluids without generating an abundance of heat. So you can imagine anytime you're pumping something viscous in nature, there's going to be friction associated with that. Trying to get a viscous product through the plumbing of any type of pump creates heat. So does an electric motor. So those two things combined usually generates additional heat. So since there is no electric motor in this case, it starts to mitigate or eliminate some of the heat buildup. And then on the other side of the application for pumping things that are flammable, although I said there's no true ignition source or electric motor, we do recommend that you use a stainless steel or aluminum pump that can be grounded. And then there are even some manufacturers on the industrial side that will offer a groundable thermoplastic pump, such as polypropylene that's been impregnated with carbon, and that also can be grounded as well. So some really nice versatility there in terms of the different types of flammable or combustible products for different industries, whether it's food and beverage or if it's on the industrial segment as well. All right, let's talk a little bit about paints, coatings, and chemicals. So one of the biggest challenges when anytime you're pumping a number of different paints or colorants is the fact that we don't want to have any type of cross-contamination of product. So the fact that you can either A, dedicate the pumps per a particular color, or B, we can disassemble them for cleaning, makes the diaphragm pump very, very attractive. In addition to that, there are some alcohol-based paints and coatings. So being that it's a inherently safe pump for that type of application, this makes it a very, very good contender as well. And then last but not least, the fact that it can handle some more viscous type products. Oftentimes we see a little bit of viscosity associated with paints and coatings. So the fact that it can be quickly disassembled, the fact that it's safe in an explosion-proof type environment, and it can handle the the high viscosity products, make it a very, very attractive pump for that. Food and beverage. So this is an interesting one. We see this a lot. And so think about your options when you're pumping a product like chocolate that sets up. So if when you're pumping and the chocolate is warm, everything is fine. But what do you do when the process is temporarily stopped or shut off? Chocolate starts to set up inside the pump. And with a traditional mechanically sealed pump, set up product on seals or on the interface of the pump, and then you turn the pump on suddenly, usually ends up with some type of damage. With a few of the manufacturers, they actually have heating elements that can be introduced to the diaphragm pump. And in that case, it actually keeps the chocolate in a very low viscosity type state, so that if the pumping process is paused temporarily, the chocolate doesn't have that opportunity to set up and then create some damage for the pump. Hey, Amy, I see there's several more questions. Do we want to address a few of those before I move on?
Sure. So one of the questions is, are the pumps ATEX certified?
Yeah, so for those of us in North America, ATEX is a standard typically associated with European manufacturers. And essentially, it is a standard for equipment that is used in an explosion-proof type zone where they need to have something that can handle solvents and things that are flammable or combustible. So here in the United States, or North America in particular, there is no true explosion-proof certification given for these. They're inherently safe, although we do recommend that they're grounded. Whereas in Europe, they actually have to be certified ATEX to be used in that type of environment. So to answer the question in short, yes, there are ATEX certified diaphragm pumps on the market.
Okay, great. Another question, can we use with a medium containing wet H2S?
I'm going to need a little help with that. I'm not so sure I'm familiar with that terminology.
Okay. Again, if there are anything, questions like that, if you can just send more information in the chat, we'll get that over to James. Another question is, how can an AODD pump be cleaned in place?
Yeah, so in that particular instance, you would hook up your CIP line to the inlet of the pump and then the discharge line as well. You would introduce the product, depending on the manufacturer, and you'd have to regulate that inlet pressure. So for that traditional figure eight design, you'd have to have some type of recirculation loop or bypass loop so that you don't exceed 12 PSI. Whereas with that center design that we showed you earlier, that can handle up to about 100 to 110 PSI inlet pressure. But essentially, you'd introduce your CIP agent to the pump. The big challenge is draining. Now that we've introduced this product and filled the entire pump with the cleaning agent, how do we get it out? Traditional figure eight designs, they typically are on a swivel stand. And so the operator would have to swivel the pump in a 360-degree motion so that it would drain out all the product. The other design, that center design that I've referenced, actually has a small channel that has been machined into the seat. And so now the pump is self-draining, so you don't actually have to rotate it. And it takes roughly 15 minutes for that CIP solution to drain out of the pump itself. So they are 100% CIP-able.
Sounds good.
We want to hit one more and then move on?
Yes, let's do that. Someone asked you to explain the CFM requirements for these pumps.
Yeah, okay. So the CFM, or that's essentially the air consumption, that is directly related to the size of the pump and how fast you intend on operating the pump. So if you think of a 1/2-inch pump versus a 4-inch pump, the 4-inch pump is going to have a greater CFM requirement to hit various levels of the performance curves. So larger the pump, the more CFM. And put it in more common terms, the larger the engine in your car, probably the worse gas mileage you get.
Great, thanks, James.
Absolutely. So let's talk about some emerging industries. So we've all heard of the CBD industry. It's something that has really come on in the last 10 to 12, maybe 15 years. One of the interesting parts of the process is the extraction process. So it's my understanding that they can be the most efficient extracting some of the CBD oils at about -30 to -40 degrees. And so that then takes a very special piece of equipment to be able to operate in that type of environment. And what we have seen is a real push for double diaphragm pumps to be used in this industry. I think, number one, they love the versatility of the pumps. The fact that, that mobility factor we discussed earlier. Number two, the fact that the pumps are stainless steel, oftentimes with PTFE or some type of elastomer diaphragms, so they can handle those really, really low temperatures. And then thirdly, the fact that they can take the pumps apart so easily and clean them. So the CBD market is growing here globally, and we're seeing a lot of opportunities for diaphragm pumps in that market. All right, time for another poll. So would self-draining after performing clean in place pump maintenance reduce time and expense of your routine pump cleaning. So essentially, when we're cleaning in place, does that reduce time and expense of routine pump cleaning for you guys? So think about your process, think about your customer's process, and what is, is the CIP something that they would actually view as a cost saver?
Looks like people answered that one pretty quickly. I'm going to go ahead and move us over to the answer.
Yes. Okay. Good deal. So I think we can all agree if we don't have to take pumps and pipe work apart for cleaning, that's obviously just going to eliminate a lot of maintenance and overhead as well. So I would like for you to be cognizant that traditionally diaphragm pumps were not used in a CIP application just because of the fact that they couldn't handle the pressure, and sometimes they couldn't handle some of the temperatures and things of that nature. But now with some of the emerging manufacturers and technologies, there are a few that can actually handle those pressures. So I would be inclined to tell you to, look around your applications when you're in plants, and if they're not using a diaphragm pump, but it seems like it makes sense for some of those key reasons we outlined earlier. And if they come back and say, well, we really need something in a CIP, just, now that you're armed with some information that there actually is that technology out there. All right, so let's get to the fun part. How do we specify the right pump for your application? So what do you need to know? So we've boiled it down to roughly 10 questions. The first being, what is the media that you're pumping? What's the liquid that we're pumping? What type of flow rate's required? What's the viscosity? Is it water? Is it 30,000 centipoise? Is it 200,000? So how viscous is it? Specific gravity. Are there any particulates? As I mentioned earlier, depending on the particulate size, you'd either want to go one or two directions, either the ball check route or the flapper check route. What's your max and min temperatures? CBD being on the very low end, but oftentimes we've got some other applications where we're pumping some pretty hot liquids. So we need to make sure that our materials of construction are going to be consistent with the temperatures that we're seeing in the application. Where is the liquid in relation to the pump? Is it a flooded suction? Is it a situation where we're going to have to draw product up 10 or 12 feet? So we need to know where that pump will be located. Where are we pushing the product to? So how much discharge pressure is going to be required? As I mentioned, with a diaphragm pump, it's a 1-to-1 ratio. So every 1 PSI in, you get 1 PSI out. If you want to figure out feet, multiply that by 2.21, and that will give you your outlet. The diameter of any existing or proposed suction and delivery. So that is a direct impact of the viscosity and the pipe work around. So obviously the larger the pipe, easier for that more viscous product to get in. And if we obviously don't want to have a situation where we have a 3-inch pump with a 1-inch inlet line or a 1-inch outlet. So we generally like to size the pumps accordingly. And then any type of certification requirements. Is this a scenario where they're pumping a food product and they need something that's 3A certified or FDA compliant? Or as we mentioned earlier, do they need something that's ATEX certified? So those are the 10 primary questions that we like to put out to our application specialists. And if we can get these answered, typically we can get you moving in the right direction. All right, we'll move on. This is that center design that I mentioned to you earlier. This is from manufacturer or brand Flowtronic. So this is what we refer to as our inside out type design. So that figure 8 design I mentioned earlier, you've got an air motor in the center and you've got your air sections on the exterior. This is the complete opposite. So your liquid end would be located in the center and your air is on the opposite side. Question is, why would you do it? Well, number one, if you have to do any type of maintenance on this style pump, you don't have to take it offline. You can literally leave it plumbed in on your inlet and discharge, remove the large nut and your air sides and air casings, and then replace the diaphragms and do any type of maintenance you have to do right there in place. And then most notable is you can see that the air motor is located on the left side there. In this case, you wouldn't have to take the pump apart at all. You can literally remove 4 Allen screws, take those off, and you can work on your air motor. So this design enables people to, number one, clean in place up to 100 PSI. Number two, take it apart very, very easy. Some of the production folks like to say it's so easy, even a sales guy can do it. And then number three, you can work on your air motor without ever having to take the entire pump apart. And then lastly, I would say the fact that the inlet is so closely located to the diaphragms, you can handle some viscosities that far exceed that 30,000 centipoise mark. And then they've got some jacketed options as well for those applications such as chocolate or even some glues for more industrial applications. And there's no lubrication whatsoever required. So just a bit of a unique design that answers a lot of the challenges in the market. Amy, do we have a few more questions before I turn this back over?
Yeah, so one of the questions asked if you could explain again how some designs are self-draining.
Yeah, so let's take a look at this design here. You see the 4 ball checks, 2 on the bottom, 2 on the top, and those sit in what's called a ball seat. So what the manufacturer's done here is we've actually machined a small channel in those ball seats. So even when the pump is not running and the ball is sitting stationary on a seat, the CIP liquid that's in the pump can still drain past that ball down through the channel, down through the bottom of the pump.
Another question asks, what about jacketing options?
Yeah, so in this particular design here, we can actually introduce a heating element to the pump. And being that the liquid end is all very centrally located, you can heat the center section of this pump so that it will enable you to pump things like chocolates or glues that can set up. There's not too many of these types of manufacturers out there.
Great. The next question is the pulsating cycle on the pump discharge subtle, less than 1 second peak to peak, or noticeable, greater than 1 second peak to peak?
Yeah, so that has a lot to do with the product you're pumping and then how fast you're actually running the pump itself. So at a very slow speed, the product kind of comes out like soft serve ice cream in a piston filler. I'm sure you've seen that before. But as the pump is cycling much faster, the peaks become very much more condensed, and so the pulsation is less noticeable. But I'd also say the thicker the product, the less pulsation, the more water-like the product, the more pulsation you'll see. So best case scenario for reducing pulsation is either a pulsation dampener or run the pump at a pretty quick speed with a very viscous product.
We're going to keep getting to questions, but I just quickly, a couple of housekeeping items. Of course, keep putting your questions in the ask question box. You can also, if you want a certificate of participation for today's webinar, you can do that by clicking the view certificate button. It should be in the bottom left box on your screen. And also there are plenty of resources there in the related content box on the bottom right of your screen. That will provide you with more related content from the Uniblock team. So take a look at those, but keep sending those questions. The next one asks, how long should an AODD pump last before it needs to be serviced or replaced?
Yeah, it's a good question. So as we know, all applications are going to yield different results. So if you're in a rigorous or intense environment where you're pumping either a very corrosive chemical at high temperatures, or you're pumping something that's very abrasive in nature, or if you have very poor air quality, maintenance is going to be a little bit more frequent. But if you're in an environment where they're taking care of the pump, they've got good clean air, you're going to see extended life. So it's really going to be dependent upon the application itself.
Okay. Another question, what is the maximum air supply pressure used on this pump? And do I need an air filter or regulator?
So a filter lubricator regulator is always recommended for any type of air powered equipment. Just, regulates air, but it also lubricates, or it also takes out the particulate. So we recommend something along those lines. Oftentimes on your more industrial compressors, they're built in already, but we definitely recommend the use of clean air.
Okay, great. The next question, can you explain how often it is necessary to clean out of place the pump?
So how often is going to be dictated by the facility and their process. So I can't really speak to that. But what I would say is oftentimes, folks are going to want to be cleaning pumps in a more sensitive type application like food or beverage at a minimum once a day. But we've seen it where it's been more frequently. Industrial applications tend to not require the cleaning quite as much unless it's in that paints and coating type industry.
Okay. Another question, does this pump use a pilot valve?
It does.
Okay, great. Well, everybody, we're getting close to time. Like I said, if you have another question, feel free to send that in. If there are any questions that we didn't get to today or may need more explanation or, feedback from the person asking, we'll get those to James and the Uniblock team so that they can answer those offline. And you'll also get an email from us later today where you'll be able to access playback for the presentation and also the resources that are available here. But please feel free to visit pumpsandsystems.com for more on this topic and additional educational webinars. I'm trying to look to make sure we're not missing any questions. There's one, any mandatory long-time preservation limitations at site warehouse for AODD?
Any long-time site preservations? I'm not so sure I understand the nature of the question.
Okay. We'll get that one to you offline. That looks like that's it. Is there anything else from you, James, before we let everybody go for today?
No, I want to thank everyone for their time, and we'd be glad to answer any additional questions you may have. So thank you.
Yes, thanks again to James for a great presentation and for Uniblock Hygienic Technologies. And thank you to everybody who took time to join us today. I hope you all have a great day.